I've got my code set up for my sound testing mechanism. All I've got for right now is pretty simple. I've got my piezo element attached to my Arduino through this breadboard. All this other stuff is for something else. But I'm going to go ahead now and show you how this thing is going to work. I've got my Soundbox set up now. This is, of course, not how it'll be in the final version because I don't want any of the actual electronic equipment inside. But I went ahead and just shoved in there for now to show you how this is going to work. I'm going to go ahead now and upload the code. Let me tell you what it's going to do before I do that, because it's going to make a lot of noise and be really annoying. I've got it set such that it's going to step up in increments of 500 hertz. It's going to start at 500, and then it's going to buzz for, I think, about 1.5 seconds to 2 seconds, but it's going to take 3 measurements of the input that's coming into analog 1, which right now there's nothing hooked up to, so it's just a totally junk number. But then it's going to output that on the serial monitor, and it's going to show me the frequency that it's buzzing at, and then the 3 measurements that it takes 1/2 second apart. And it's going to do this from the number I specified, which is 500 hertz, all the way up to 30 kilohertz. That way I can get a range across all the different frequencies. Now, obviously, I'm not going for absolutes here because I don't have any way to calibrate this against the decibel scale or anything like that. But it's going to give me a really nice way to see which different materials and thicknesses and this and that, give you a good amount of sound insulation. So I'm going to go ahead and upload it, and it's going to start making noise. So I went ahead and unplugged it because that's pretty annoying. I've also found that this little element, piezo element here, doesn't respond so well to certain frequencies, I guess. It wasn't stepping properly or something in some cases. So I'll do the actual test, of course, with the actual speaker element. But I don't know if you can see it here, but on my serial monitor, I've got all my frequencies and stuff coming out. So right now, it's just passed through 19 kilohertz. It's given me 3 readings then, which are totally bogus, like I mentioned, of 270, 268, and 268. Since I'm taking off the analog pin, it's going to be 10-bit, so from 0 to 1023. I will hook up a microphone circuit or something, and then the plan is to simply try fiberglass insulation, of course, expanded polystyrene, put things in front of this, various thicknesses or whatever, and then have the microphone sensor maybe 1 foot or 3 feet away, stationary out here, in line with this, of course, and to have a fairly nice, test setup. So that's what I'm hoping to do soon. But that's how all that works. This test is just about finished. It's going to run all the way up to 30 kilohertz and then stop and then tell me how long the test took, which I think at this rate is 180 seconds based on my previous trials. But that's how that works. I'll give you this code here if I can here in a bit once I get it all perfected. But thanks for watching. I really appreciate it.